Let's get started. So we started off with figuring out what cosine A minus B was. And today we're going to figure out other composite argument properties. We're going to derive them. And hopefully you enjoy them. Hopefully you enjoy these. We'll see, how much you guys like them or not. Let's just start. So it starts off by looking at some graphs here. We really haven't studied tangent too much. So I kind of blame this on the pandemic. Not that it's not fun. Tangent is a lot of fun, but we haven't studied it as much as I would like. Like we've done sinusoid, so we've done sine and cosine, but we really haven't studied the graphs of tangent, cosecant, and cotangent, secant, and cosecant. So hopefully in the future we'll do that, guys. Sine, notice that it goes through the origin, and if you do flip, so sine is known as an odd function. And there it is. That's what makes it an odd function. Notice that cosine is symmetric on the y-axis, guys. So cosine is known as an even function. And we're not doing anything too crazy. Stop me if you guys feel like I'm doing stuff that is way overboard. And then tangent is symmetric about the origin again. You can do something called flip. Don't call it flip because this is not a technical word. So if you go to the high school, if you go to the university and you say flip, tell the professor you're from like Jefferson High School or something. It's an odd function. And I was kidding. Don't tell the professor you're from Jeff. Tell him you're from Brack. So all right. If sine and tangent are odd functions, then that means their reciprocals are also odd functions, guys. So the reciprocal of sine is cosecant. So cosecant of negative theta is the same thing as negative cosecant theta. That's because cosecant is an odd function. Hey, hell. Yeah, go for it. Do you have my Zoom link?
No.
Oh, man. Okay. Well, here's what we're doing. Hold on, guys. Give me 30 seconds. They're all in my little...
No, you're good. Oh my gosh, these desks are amazing, by the way.
Yeah, I approve hardcore. All right, the same thing for cosine, guys. If cosine is even, then the reciprocal of cosine, which is secant, is also an even function. So secant negative theta is the same thing as secant of theta. And then the same thing for tangent, guys. Cotangent negative theta is equal to a negative cotangent of theta, because cotangent is an odd function. What do you think, Ms. Parker? Everything pretty simple so far? Awesome. All right, I think those are straightforward. Here they are again. They give you the properties. I want to say this is coming from a textbook. Can't remember which one. I want to say Paul Forrester's. So let's keep going. Go to the next page. And on the next page, it says the cofunction properties of 90 minus theta and pi over 2 minus theta, or phi, if you want to call it that. If you look, and yeah, sorry, when I was making these notes, I was feeling like funny, but now that I'm reading it, it's like, yo, Chavez, draw. No, it's not funny. So erase the yo there. So if you look carefully at your sinusoidal functions, guys, your cosine and sine, you'll notice that both of them are out of phase by 90 degrees. So what I'm trying to say is, so let's draw a right triangle real quick. And I'm going to do a 30, 60, 90 in particular. So 30 degrees, 60 degrees. And I'm going to call the hypotenuse 1. So 1. So in a 30, 60, 90 triangle, we have n squared root of 3, and 2n. Hopefully you guys remember that. So if the hypotenuse is 1, that means the short leg is a half, and my long leg is square root of 3 over 2. And these should not shock you because those are coordinates on the unit circle. So 30 degrees. So I'm going to say this is my short leg, that's a half. There's my long leg, square root of 3 over 2. Is anyone confused at the moment? Okay, perfect. So I want you to make an observation. So check this out, guys. I'm going to write cosine of 30 degrees. Cosine of 30 degrees is adjacent over hypotenuse, or if you remember from the unit circle, square root of 3 over 2. And now here I'm going to put sine of 60 degrees. And notice that it's the same value. And don't worry, we're going to make a connection. Now I'm going to write, let's see, I'm going to write cosine of 60 degrees. And I'm going to put half. And I want you to notice that sine of 30 degrees is also half. All right, Chavez, I already knew those from the first semester. What's your connection? Here's the connection. I want you to notice that both of these add up to 90 degrees. And both of these angles here add up to 90 degrees. All right. So what? So they add up to 90. What's the big deal? The big deal is this. I can rewrite cosine in terms of sine if I just do this. Sine 90 degrees minus theta, and it will work. See? If I were to type theta in for 30 degrees, so I'm looking at this one in the top with the blue lines connected, cosine of 30 degrees is square root of 3 over 2. If I plug in 30 degrees here, 90 minus 30 is 60, and sine of 60 degrees is also square root of 3 over 2. So do you see how it works? It's also, you can also look at the graphs, guys. They're 90 degrees out of phase. So if you plot both of these graphs, it's going to be the same wave. Same thing with sine, guys. Same thing with sine. If I write cosine 90 degrees minus theta, you will get the same deal. So look at the second line here. So if I make theta 30 degrees, so sine of 30 degrees is a half. Well, 90 minus 30 is 60, and cosine of 60 degrees is also a half. So it works. Do you see how it works, guys? All right. Do we have
an explanation one more time of the sine one?
Oh yeah. Pick a degree in the unit circle, any degree. Which one? Besides the 45. Pick one in the first quadrant. Besides 45. So 30 or 60, it doesn't matter. Or you know what? It doesn't even have to be a perfect coordinate. Give me any number between 0 and 90 degrees.
36.
36. Put your calculator in degree mode and see what cosine 36 degrees is. And don't worry, I'll change it right now. And then I'm going to go 90 minus 36 degrees. So let's see. I'm going to use my Desmos. So let me get Desmos out. So I'm going to internet here and then share screen. Desmos. And then, by the way, you can also see it just really quickly because cosine and sine are 90 degrees out of phase. But that's not the point. We know they're 90 degrees out of phase. I just wanted you guys to see this property. So check it out. You guys say 36 degrees. Cosine 36 is that number, 0.809. Now look if I type sine 90 minus 36. And OMG, it's the same number, digit per digit, all the time, 100% of the time.
If you just wrote it as sine and then 54 or whatever that is actually, would it do the same thing?
Yes, sine 54, there it is. Cosine 90 minus 54. And there it is, same thing. See? Yay.
And that applies to any angle, only in the first quadrant or anywhere?
Anywhere, sine and cosine. There, if you were to graph, so I guess, look, watch. So here's my graphing calculator. And right now I think it's in radian mode. So if I were to graph sine, cosine, if I were to graph sine x, notice that sine x and cosine x, look, you see that peak there, that's at pi over 2? If I drag that pi over 2 right over the y-axis, it's the same as cosine. So if I go cosine, and then I write pi over 2 minus x, it's the same as sine. See, look at the blue one. It's the same curve. And it works the same way. You can alternate them back and forth. Cool, right? Very cool. So these are the same. All right. Now we know everything we need to know to be awesome. So let's be awesome. Here it is in degree mode, guys. Here it is in radian mode. Remember that pi over 2 is 90 degrees. And I think we're ready. All we need to know, let's see. All we need to know is this argument, cosine of A minus B. Hopefully by now, it's pretty easy. Do we have a volunteer that wants to give me this formula here? Is it plus or minus?
Plus.
Yeah, it's plus. Cosine A, cosine B plus sine A, sine B. So here's how we're going to do it, guys. We're going to use this formula, and we're going to trick. See how it has a minus there? So I'm going to write this. I'm going to write cosine A plus B is the same thing as saying cosine A minus a negative B. Is that a true statement?
Technically, yes.
Yeah, it's a true statement. So I'm going to use the same formula here, guys. That A is that A. And instead of saying B, I'm going to say negative B. See? So I'm going to expand. So I'm going to expand this formula that I have with the star on it. And I'm going to write cosine A, cosine, open parenthesis, and I'll put negative B, because that's what my angle is. I'll put plus sine A, sine of negative B. Have I confused anyone? All right. From there, look back at your notes on page 1. Cosine, is cosine an odd function or an even function?
Even.
Even. And sine is a
Odd.
odd. So I'm going to use those properties. Oh man, zoomed in there too much. And because it's an even function, I can just drop that negative. So this is cosine A, cosine B. And then because sine is an odd function, I can move that negative on the outside, and I'm going to write minus sine A, sine B. So now I have two formulas. So now I can say, so cosine of A plus B is nothing more than cosine A, cosine B, minus sine A, sine B. So now you got two formulas in your toolkit. Wasn't that cool?
I have a question.
Ask, what's up?
Okay, so since cosine is even, that's why it's still cosine B, but the minus come from the odd function, the sine?
Yes, from the odd function. We said sine of negative B is equal to a negative sine B.
Okay.
So that negative, I pulled it out, and positive times a negative is a negative.
Okay.
Any other questions, guys? Okay. All right, guys, let's keep going. Now, I think we're ready for this one now. And no, I'm not going to do the universal math gang sign. I was feeling silly when I was typing these notes, and now that I'm here, I'm like, nah, I'm not going to do that. So let's go ahead and see if we can figure this one out. So let's see, what do we know? We know cosine A plus B, and we know cosine A minus B. Well, I know, let's see, this is a whole angle. So I know that I can go sine of A minus B equals cosine, and look at page 1 again, or it might be page 2. I already short-term memory here. And I can go 90 degrees minus the angle A minus B. These are equivalent. All I'm doing is this. I can see some faces already. All I'm doing is this, guys. Let's see, I'm doing this one right here. Sine of A blah, blah, blah is equal to cosine 90 minus that angle. And I group the A plus B. Are we cool right now? Or the A minus B, sorry. All right, now I'm gonna go ahead and distribute this negative, guys. So now I have cosine 90 minus A plus B. And you can already see what I'm going to do. Or I don't know, maybe you can't. It does take a little bit of experience. I am going to group together the 90 minus A. Because we have a formula that we just derived, and it's right there in the top here in black with a black star. It says cosine of some angle plus B equals all this stuff. Well, I have cosine of some angle plus B, so I'm just going to use that formula again. Taylor, do you see what's going on here or no?
A little bit, sort of.
Yeah, this 90 minus A is like that. Is like that A right there.
Oh, okay.
Okay.
Okay, so you're just making 90 minus A one unit. And then,
Correct.
okay.
Yeah, one argument. Or that's one of my arguments. All right, so here it is, guys. I'm going to write cosine. And I'm going to write 90 minus A instead. Put the little degree symbol there. Cosine B minus sine 90 minus A sine B. What do you think, Ms. Godina? Are we still okay? Godina. Okay, yes. You were this close, Miss. Just right clicked on you. All right, from there, let's see. From there, look at this. That is a particular, what do you want to say? Identity? I don't want to call it identity. Particular property, we just talked about it. Cosine of 90 minus A is the same thing as?
Sine
of angle A, yeah, sine of angle A. And then I write cosine B. I bring this minus sine, and then sine of 90 minus A is equivalent to cosine. And now we have another equation, guys. So, and I guess I'll go back to red here because red's such a nice color here. So what? So sine of A minus B is equivalent to sine A cosine B minus cosine A sine B. So notice the argument property for sine is the one that toggles sine, cosine, cosine, sine. And the argument properties for cosines do not toggle. Travis, what are you talking about? Talking about this, guys. If you have a cosine, 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 sine, sine. If this is a plus symbol, then it's the opposite. I have a minus. That's for cosine only. But for sine, if you have a minus, you keep it. So take a guess. This is another one. Put that in the rectangle. Take a guess. We're not going to derive this one. I think we can figure this one out from the previous stuff that we just did. We can make a conjecture. So what do you think sine A plus B is?
Sine A cosine B plus cosine A sine B.
Perfect. Now for the quiz, I will let you use a formula chart or a cheat sheet where you can put all these formulas. But for the exam, guys, and I know that I can't 100% control everyone, but for the exam, I would like for you not to use any formulas. There it is, guys. I think we're winning. Let's see if we can do an example with this. Now, where do these questions come up? This question I stole. Well, I guess I should I didn't steal it. So because I'm about to put my source here. So I didn't steal it, guys. This question is from a UH math competition. Now, for those of you that are unaware about the UH math competition, guys, you have 1 hour and no calculator usage. So you can't use the calculator. So at first glance, you're looking at it and you're like, okay, how am I supposed to do this without a calculator? Well, here's how those kids solve this question, guys. The ones that everyone's like, oh my God, they're so smart. No, it's not that they're smart. They just have more experience. That's all. That's all it is. Look, you notice sine, cosine, cosine, sine. And then you notice, oh, that's a 5x. I have a 5x there. Oh, 3x. That's a 3x there. They keep the angles the same. So you recognize this sine, cosine, cosine, sine, and you're like, wait a minute. That looks a lot like a composite argument property for sine. We just did it right now. We just did it right there. Look, there it is in the top. See? So in case you don't know what I'm talking about, I'm going to write it right here on the top, guys. Sine of A minus B is equal to sine A cosine B minus cosine A sine B. It looks exactly like that. So what those kids did, I don't know why my computer keeps doing that. So what those kids did, guys, they said, oh, okay, that 5x is like your A, that 3x is like your B, and they can rewrite all this expression on the left-hand side as just a single sign. Sine 5x minus 3x, and then what I have on the right-hand side, keep it, equals a half. So catch up, get up to there. And then from there, guys, what's 5x minus 3x? Can we do that without a calculator? Yeah, just 2. Sine of 2x equals a half. Now you're going to need a little bit of knowledge of your unit circle, but it's not even extreme, guys. Now I'm going to do the inverse of this. Inverse. So 2x equals arc sine or inverse sine, whatever you prefer, plus 2 pi n. On the unit circle, where is sine a half? Am I in degree mode? No, I'm in radian mode. I'm in radian mode, guys. The first time it happens is when the angle is pi over what?
Pi over 6.
Pi over 6. Make sure you know that, guys. I know because we're in a pandemic year, I think a lot of you are probably more accustomed to looking at the unit circle, but see if we can make sure that we got certain things down like stone cold. So there's my first equation, and I'm going to write my second equation in blue. 2x equals, the other time it happens, I'm in quadrant 2 on the unit circle, and that is 5 pi over 6. All right, I'm just going to solve, guys. I want to get x by itself. A lot of you make this harder than it really is. I don't know, you do like keep, change, flip, and I get it. That's what they teach you guys of how to do fractions, how to divide fractions, all that good stuff. Look, divide by 2. Just put the 2 next to that 6 there, guys. X equals pi over 12 plus pi n. That's 1. That's a general equation. Divide by 2. Put the 2 next to the 6. Divide by 2. X equals 5 pi over 12 plus pi n. Chavez, I don't know how to get common denominators. Guys, it's not hard. Look how easy it is. I have a 12 in the bottom. 12 over 12. 12 over 12 is 1. 12 over 12. Let's find out all our solutions. X equals, one answer, pi over 12. Another answer, 5 pi over 12. Another answer, common denominator, 12 plus 1, that's 13. 13 pi over 12 is definitely smaller than 2 pi. Chavez, how do you know? Because in the top, I don't have a 24. 24 divided by 12 is 2. So as long as my integer value in the numerator is smaller than 24, you're good. 12 plus 5. Uh-oh, 12, 5, 17. I make mistakes all the time, guys, so make sure I know how to add this. So there it is. If you were to add another pi, then you would be outside. And there it is, guys. So those kids that are solving these questions, they're not necessarily, okay, yeah, they're smart. Everyone is smart. But I don't want you to be intimidated by them, guys. They just have more experience than you. They've been exposed to all these problems before, so they know how to tackle them. So that's the key, really, that's the key. Just, do you have enough time to invest in solving these types of problems? Where are you gonna solve these? I think I read an article on the SAT that subject exams are going away. I think I just saw that yesterday, but I haven't read it all, so don't quote me. Where do you see these type of questions in the SAT? You won't see it on the regular SAT. You'll see it on math, it's a subject exam, level 2. So it's a level 2 math subject exam. Now they may be going away, guys. So if they're going away, well then I guess we don't have to worry about these. But if you want to take a subject exam while you still can, I think this year is still good, I think. This is going to come out in the math subject level 2 exam.
What are the subject exams?
Subject exams are just a way to show universities that you know a certain topic like very well. So you can take, for math, there's two of them. There's the level 1, which is just the same as the regular SAT, algebra, geometry, algebra 2. And then there's a level 2 that has statistics, pre-cal, advanced algebra, conics, stuff like that. So it's just a way for you to show universities that you know you're pretty good at a certain topic. All right, we're gonna derive one more. We're gonna derive tan of A minus B. So this is the last one we'll derive, guys, don't worry, and then we'll have some fun. Tan of A minus B. We know that tangent is sine over cosine. So I'm gonna write sine A minus B over cosine A minus B. And I already know what sine of A minus B is, I hope. And don't worry, if you don't have it memorized yet, you can reference it. Sine is the one that toggles. So sine A, cosine B, and you keep the sign, that's a minus, so minus cosine A, sine B. And cosine is the one that does not toggle. So cosine, cosine, sine, sine, and then opposite sign. So cosine A, cosine B, plus sine A, sine B. Now, I did cheat, so I will agree that this is kind of cheating. I do know that the format of this equation here, they have a 1 on this corner. I want this expression to be a 1. If I want that expression to be a 1, I got to divide by what I got to do. What do I got to do to make cosine A, cosine B a 1? How do you make anything a 1?
Wait, really quickly, I'm confused by why, like, why do you want that to be a 1?
Oh, because I cheated and I know what I want the equation to be.
Oh, okay.
How do I turn anything into a 1, guys?
Divide by itself.
Yeah, perfect. Divide by itself. Because we have it in here, we have an equation here. If I divide that by cosine A, cosine B, I have to divide every term by cosine A, cosine B, or else it's magic, or else you're really just changing that one term into a 1 and that's it. And you can't do that, that's magic. So I'm gonna rewrite the same thing, but I'm gonna leave some space, guys. So here it is, I'm rewriting the numerator, sine A, cosine B, minus cosine A, sine B. And I'm leaving some space. Notice that I'm leaving space there, guys. Cosine A, cosine B, plus sine A, sine B. And just like Taylor said, I'm dividing by itself. Whatever you do to one, you got to do to all of them. So I'm going to divide everything by cosine A, cosine B. So divide everything by cosine A, cosine B, guys. Cosine A, cosine B. And I should have done it in red, but oh well. And we're almost done. We're almost done. All right. I'm going to cancel whatever allows me to be canceled. Cosine B, I can cancel that. I mean, I guess you can also call it times 1, but let's just cancel it. Cosine A, you can cancel those. And it looks like that's it. This is a 1 now. So here's my new equation. Sine A over cosine A, that is a tan. Tan A. Minus sine B over cosine B, that's the same angle. That is a tan. Tan B. Over cosine A, cosine B over cosine A, cosine B, that's a 1. Plus sine A over cosine A, that's tan A. So this must be a product here of tan A and tan B. So from that, we know that, do I have enough space? Yeah, I have space.
Wait, hold on really quickly. Can you explain how the fourth part became tan A, tan B?
Yes. You see this sine A over cosine A? That's tan A. And then the sine B over cosine B, that's tan B. So this is the product of tan A times tan B. Did I answer your question, miss?
Yes.
Okay. So now we have another equation, guys. tan A minus B is equal to, and yes, I will agree. You have to know on this one that that's what you want on that little corner there. So this one is tan A minus tan B over 1 minus tan A tan B. Now, tan is not super special. You still got to know it. Is it 100%? Like, do you got to know it throughout life? Probably not. Like, it's not going to help you open up a checking account or anything. So, I mean, they're not going to ask you, right? Like, before you open up this checking account, can you tell me what the composite argument of tan A minus B is? Yeah, they're not going to tell you that. For engineering, I think it is important. Not as important as sine and cosine because that's a wave. So the waves are the ones that come out all the time and everything. But yeah. All right, look what you guys just did. Go to the last page. You guys have just derived every single one of those formulas. I hope that you're excited. I hope that you feel like you're getting a quality education. Look how boring it would have been if I would have just told you, guys, here's the formulas, just use them. I don't know where they come from, just use them. Like, don't you think that would have been boring? Or at least, like, that wouldn't have been doing you guys a service. You guys just derived every single one of them. This is the first one we derived. And I don't know if you remember, but we derived this with a unit circle and distance formula. And then after we derived that, today we did all of those. Well, okay, quote unquote. We derived the cosine A plus B, we did the sine A minus B, and then we did a conjecture for sine A plus B. And then we just did it. Well, I didn't have that conversation. I should have said, what do you think tan A plus B is? And we would have made a conjecture that it's the same thing as tan A minus B. The only difference is the signs. But I didn't have that conversation. So my apologies. I hope you don't feel like you're being cheated. How do we feel, guys? Do we feel okay? All right. So here's the deal. So I have an assignment that I've already uploaded to Canvas. You can, if you're fast enough, you should have enough time to finish it before 10 a.m. I put the due date for 7 p.m. That does not mean like, oh, I'm not going to do it. I'm going to stay here, guys. And if you have questions, I'm going to be available during asynchronous time.